Should I learn JavaScript?
Learning JavaScript is definitely beneficial, especially if you are interested in website development, web applications.
Hey everyone! In this tutorial, we are going to build a 3D AI school. The idea is to create a virtual classroom where you can interact with an AI teacher. You'll be able to ask questions through text or speech, and the teacher will respond with both text and voice. It's an interesting way to explore how AI can be used in education and to create an engaging learning experience. Building this project will also give you practical experience with some powerful web technologies. For this tutorial, we'll be using Three.js for 3D graphics, React 3 Fiber to integrate Three.js with React, and OpenAI's ChatGPT API that you already know for the AI conversation capabilities. So let's start by understanding the key tools we'll be using. Three.js is like a toolbox for creating 3D graphics on the web. It provides a wide range of tools for creating and displaying 3D scenes in the browser. It's very flexible. You can create simple scenes or complex, detailed worlds. Then we have React 3 Fiber, and that is a way to use Three.js within the structure of a React application. It's like a bridge between the world of 3D graphics and the world of React components. Then there is also Dry, which is a collection of helpful add-ons and abstractions for React 3 Fiber that will make certain tasks easier. Like, for example, adding lights, shadows, or loading the 3D models, etc. It's like a set of utility functions that you can use to enhance your 3D scenes. But you might ask, why then use React 3 Fiber over plain Three.js? Well, first of all, React is very popular, and also recruiters are looking for React developers, so you have an easier time to look for a job. It has a great community. It's a great library maintained by Facebook. But also with React, and in this case, React 3 Fiber, to use 3D graphics, we can leverage the component-based structure of React, because this makes our code more modular and reusable and easier, of course, to understand. It will abstract away some of the complexity of Three.js, allowing us to focus more on creating our 3D scene. So this is the reason that we are going to use React 3 Fiber, even though I really love also playing Three.js. But if you are looking to work in a React environment, this is the best choice. Throughout this tutorial, we'll use these tools to build our virtual classroom step by step. We'll create the classroom environment, we will add interactive elements, we'll bring our AI teacher, add animations to it, to play it dynamically, interactively, and then set up the AI conversation capabilities. I've structured this tutorial to be accessible even if you are new to these technologies. So we'll start with the basics and gradually we'll add complexity. Each part of the tutorial will include explanations of key concepts, live coding, because we will code live, and I will try to add visual ads when possible to help you understand. Okay, so by the end of this tutorial, you'll have a solid grasp of Three.js, React 3 Fiber, and how to integrate AI capabilities into your web application using OpenAI API. Actually, I wanted to use Cloud. Cloud is another language model like ChatGPT, and I'm very happy with Cloud. especially with the premium version, which is, I think, Cloud Opus. Yeah, Cloud Opus. And to be honest, in some cases, it performs way better than ChatGPT, at least for me, for coding challenges. And I really challenged the AI because I tried with very complex problems that are very specific. So it's not just a collection of information to and the ability to respond, like grabbing some information, but also using a bit of logic, specific things that maybe you cannot find everywhere. And cloud, I don't know, but it adds context. It understands the context. It remembers very well the earlier conversation and has like a human-like way of expressing. And maybe I will continue to use cloud more than ChatGPT. But anyway, since ChatGPT is way more popular than the Anthropic cloud, I thought that, okay, let's use ChatGPT for this, because maybe also there are more users of ChatGPT and they are familiar with it. But yeah, I wanted to say that I really like this cloud and I wanted to use that. But anyway, this is not an advertising on Anthropic Cloud. It's just my personal opinion. Okay, so let's get started. And in this part, we'll set up our development environment and lay the foundation for our 3D AI classroom. All right, let's dive into the coding part of our tutorial. First, make sure you have the necessary tools installed. You'll need Node.js and the code editor like Visual Studio Code. Okay, please install them. So go to Google, search for Node.js, download, install. Also the same thing for a code editor like Visual Studio Code. So after installing Node.js and Visual Studio Code, let's set up a new project using Vite, which is a build tool to create React projects or Vue.js or JavaScript projects. It is very fast and it's better than other build tools. So search here Vite, getting started, click the first result, and here you will see the documentation. And here in the getting started section, scroll down, you see this short command, npm create Vite latest. Copy this. This is to create a new project with the latest version. And then you will choose if you need a React application or a Vue or JavaScript application. You will see yourself. Copy this. Go again to a Visual Studio terminal. Open the terminal. Paste this npm create Vite latest. But first, you should choose where to create this project. For example, I want this project in my desktop. So navigate to the folder that you want to create the project, cd, desktop in my case. Make sure I am in the right directory. Okay, I'm in the desktop. Now I can create the project. So run the command npm create Vite add latest. So add a name to it. I will call it simply 3D School. Then choose the framework or the library. Here, for example, Vanilla, JS, Vue, React. We will choose React. Then choose a variant, TypeScript or JavaScript. We will choose JavaScript. And we are ready. So just jump into this folder, cd 3D School. Now let's install the dependencies. The dependencies are the node modules, so the external packages that we need to be able to run a React project, okay, using Vite. So let's set up the stage, the scene of our project with all the actors and what we need, the packages. So all these external packages we'll make sure that we build our React application with all the useful packages. Let's say we set up this stage, this scene, with all these actors that will make sure that the play will be good. Okay, so for that, npm install or shortly npm I. Wait a few seconds. Byte is fast, so you won't wait for too long. Next, we'll install the necessary packages, but in this case for Three.js and React 3 Fiber, because we installed with npm I all the node modules, that usually what we need to set up a new project. But here we need the packages for Three.js and React 3 Fiber and additionally dry, okay, that we mentioned at the beginning of our video. For that, run this command npm install 3, which is to install the 3 library, then add react-3/fiber to install fiber, and also React 3 dry, okay? Make sure to run this command correctly. Wait a few seconds. We now have the 3 and the React 3 Fiber and dry packages, okay? Let's open the project that we just created. Desktop, 3D School, okay. You see, we have now these new files and folders. We are not going to explain each file, what it means, because yeah, you have everything that you need to know on internet. Just find a good tutorial on the very basics of React. What is, for example, main JSX, what is the use of app JSX, what is package JSON. So you should know already the structure of a React project. Anyway, we are going to explain everything step by step, the code that we write, and everything else, but we are not going to stop and discuss each of the files or the structure or, these details, because you should know by now, but if not, you have like thousands, if not millions of tutorials out there on React. But anyway, I will say that this is the main folder that we will use and put all our components, so src folder. The public is to put all the static files, the media, the 3D models, etc. So this is the folder. We will clean up a bit here. The index file is the file that renders in the browser. It's a simple HTML file which has this ID of root that React target this ID of root in the main JSX. Here you see get element by ID, root, and render. Okay, more in depth, you can find the tutorials online. First of all, let's clean a bit. For example, these styles for app JSX, delete them. The global styles in index CSS, also delete them. I will replace it with some default styles that I have. Simple styles, just to make sure that the Canva is like full width and height, and some really basic styles, okay? You can just copy and paste, find the link in the description to the GitHub repository and just copy and paste. We also will delete this app.js main component of a React application. We will delete everything here because we will build our application from scratch. Okay, maybe here in the main.js, we need this index styles application. Okay, this is okay. Create a new React component here. I have a shortcut, so RFCA, enter. It will create a new React component with export default. I don't like this slint warnings, so I will disable them. You can disable like this, like click and disable for the entire file, or you can add this to the slint file. For example, take a look here in the slint file. Here, where it says rules, you see there are some rules. String, add this no used vars strings again and off, comma here. And now if I delete this, I will not get the warning again. Do this for, you need these lint warnings, but this time we don't need them. Now that we have this main component, is just a simple component, okay? We can also delete this React from React. It just returns a new div with the text up. You see this up here is just a simple div. All right, let's break down the concepts and the code in this React component in a beginner-friendly way for this tutorial, okay? Please, if you are not a beginner, but you know these things, bear with me, please, and skip this part. For the other beginners, please follow me. In React, a component is a building block of the user interface. It's a self-contained piece of code, like this one, that describes a part of the UI. This component is just a part of the whole application. Components can be thought of as reusable pieces of a puzzle that you put together to create the whole picture, in this case, your application, okay? So small pieces of a puzzle to create the whole picture. Components in React are typically written using JavaScript functions like this one, or classes, but we don't use classes anymore in React, so you don't really need to know the classes components anymore. They can accept input data called props, accepting them here in the parentheses like normal JavaScript arguments, because we suppose that you know the basics of JavaScript, okay? So these are called props and are input data. And this React component returns React elements that describe what should appear on the screen. In this case, we simply make appear a simple div with the text up. Okay, so returning this div element. The beauty of components is that they allow you to break down your application into smaller manageable parts, like this one. Each component can have its own structure, its own style and behavior. For example, you pass here a file that has the styles. For example, the app CSS. Import /app CSS. And then this component will have the styles of this. And usually you put it in a separate folder. So call it, for example, app, and then inside you have the JSX component and the style component. We can maybe explain also what JSX extension is. So we said that this component can have its own structure, style, and behavior. And we can then compose these components together to build a complex user interface. Here, in this function app, which is the app component, let's take a look at the code. This is a simple functional component in React. It is called a functional component. Let's break it down line by line. Function app. This line declares a JavaScript function named app. Simple as that. In React, you can define components as functions. The naming convention is to use Pascal case for component names. Okay? You know what Pascal case is. So, for example, app, and again, uppercase, component. Okay? The next line, return div element with the text app inside it. This is the body of the app function. It returns a single JSX element. which is a div with the text up inside. For the JSX, to explain it, what JSX is simply a syntax extension for JavaScript that allows you to write HTML-like code within this JavaScript, okay? So JSX is a syntax extension for JavaScript that allows you to write HTML-like code within your JavaScript. So in order to use this HTML-like code, like this div, inside the JavaScript code, you use this JSX syntax, which React uses. Actually, you can use it outside React as well, not only in a React application. But JSX is popular because it is used in a React application. So in this case, the app component is simply rendering a div element with the text up. This is what will be displayed on the screen when this component is rendered. And to render it, we said that you simply run the command npm run dev. You will run it live. Click the URL and you will see the result. You see, we are rendering this app text, which is a simple div with a text up inside. And that's it. Now, the last line, export default app. This line exports the app function as the default export of the module. It allows other parts of your application to import and to use this app component. When you have a default export, you can import the component using any name you choose. For example, here, let's say in another component, you see here import app from app.jsx. But you could also use import my app from app.jsx. And here also we have an error because you should also change here, okay? And is completely fine. So you can choose the name here if it's an export default. Something else is if it's not an export default, but it's export function up. In that case, here you will import it like this with curly brackets. Import app from app.jsx. Okay? Usually we use export default for the main application here. And the other components you can use export const, app, etc., etc. So, to recap, this app component is typically the root component of your React application. It serves as the entry point and can contain other components within this, okay, to build the complete user interface. As we will continue with our application, you will create components like, for example, environment, which is the component that we will create now, and import it here in our app component and other components as well. Remember, this is just a simple example of a component because as your application grows, your components will become more complex, accepting props, as we said, maintaining state, and defining more intricate rendering logic. But for now, just remember this, what we said, that each component is a puzzle piece to create the whole picture. Now, first we create a new file called environment.jsx in the src folder. This file will contain our Three.js scene using React Fiber. Okay, so in src, create a new folder, name it components, and inside create this file, environment.jsx. Again, create a simple component first, rfc, and inside of this, we don't want this simple div, but we will import canvas that I will explain in detail what it is. Again, this slint warning, I don't want these warnings. So grab this, go to slint file, rules, off. Okay, leave me alone, slint. I know what I'm doing, or I think I know what I'm doing. Environment JSX. So to import this canvas, you can do it like this. You see here the suggestion, canvas from React 3 Fiber. Okay, you get it. Now we have this canvas component, and I will explain now why I imported it, what is canvas, and why we need it. So in React 3 Fiber, the canvas component is the fundamental building block for creating 3D scenes. Okay? It sets up a Three.js scene, a camera, we need a camera, and a renderer. We are going to explain them. So a simple scene is built with the Three.js scene, a camera, because you need a camera to look at the stage to be able to render or to film it. Okay? Think of it as you are like the director and you are making a movie, a good movie, I hope, and you need a camera, okay, to film it, to look at the stage. So a simple scene, it has the stage, the scene, a camera for the director, and a renderer. A renderer is like the snapshot of the camera. Okay? So you need to snapshot that what you are looking at the camera. For now, this simple explanation for the renderer and for the camera. But let's continue with the meaning and the use of canvas. Think of the canvas as a container where all your 3D content will be rendered. Okay? It's like a blank canvas waiting for you to paint your 3D scene on it. The canvas component takes care of the complex setup and rendering process behind the scenes, allowing you to focus on creating your 3D objects and scene composition. It's way easier here in React 3 Fiber than in plain Three.js. In plain Three.js, you have to do that all manually. Okay, so the rendering part, the camera setting, the scene setting, etc., etc. And also the updating, which you do it with the animating loop function in Three.js. But we don't need to discuss in React Fiber these things, okay? We have canvas and we have what we need. Under the hood, the canvas component utilizes the power of Three.js, as I said, for displaying these 3D graphics in the browser. And Three.js provides a wide range of features and functionalities for working with 3D scenes. So Three.js provides geometries, materials, lights, and more that we will discuss step by step. But you should know that by using React 3 Fiber and the canvas component, you can leverage the declarative and component-based nature of React for building your 3D scenes. You say, I want the canvas here, and you get the canvas here. Okay, simple as that. I want the canvas here. I want light. Let there be light. And you call that component. When you define these 3D objects as reusable components, you can compose them together and manage their properties and behavior, like using React states and props, okay, as you usually do in your React applications. The canvas component also provides various configuration options and event handlers, allowing you to control the camera, the rendering settings, and interact with the 3D scene using mouse, touch, or other input devices. Okay, so this is a brief explanation of the canvas in React 3 Fiber. Okay, I want to take a moment and dive deeper into this main concept of Three.js, because we said that we import the canvas into our React 3 Fiber application, and we have the full option with the renderer, the scene, and the camera inside. So we don't need to set up anything, like the scene, the renderer, etc. So we just import the canvas, and we are good to go. But what really happens under the hood? And what is the real meaning of these components? So I would like to go deeper into these concepts, because with the exception of the canvas, which actually is specific to the browser, an equivalent to each of these components can be found in any 3D graphics systems. So it's very important for you to learn these concepts, making your knowledge that you will gain highly transferable. Okay, so let's go deeper into these components. At the heart of every Three.js application, we have these three essential components that we mentioned: the scene, the camera, and the renderer. This forms the basic scaffolding of our 3D world. The scene that you see here at the center is our tiny universe where all our 3D objects reside. It's a container that holds everything we can see in our 3D space. Here you can see that the mesh is what the scene can hold, and this mesh can be anything. We saw some basic geometries. In Three.js, we create a scene using the scene class, which is imported from the 3 module. Like we imported canvas from React 3 Fiber, we import the scene class from the 3 module if we are in our Three.js project. The scene defines a coordinate system called world space. This coordinate system serves as our main frame of reference for positioning and manipulating objects. You see here in this picture, the center of the scene is the origin, represented by the point 0, 0, 0. Whenever we create a new object and add it to the scene, it will be placed at this origin by default. So every object by default will be added at the origin 0, 0, 0. We can move and position these objects within the world space coordinate system. Additionally, when we add objects to the scene, they are placed into the scene graph, which is a tree-like structure with a scene at the top, as you can see this picture. This hierarchical structure allows us to organize and manipulate objects in a logical and efficient manner. You see the scene at the top and then the mesh inside this scene in a tree-like structure. Does it look familiar to you? Because this scene graph is similar to how elements on an HTML page are structured. You see, at the top, the doc type HTML, then we have the body, the head, and the divs or h1 elements. This is similar, but except that the HTML page is 2D, not 3D, while the scene graph is 3D. So we have this scene that holds all the 3D objects, and then we have the camera. If the scene is our tiny universe, the camera is our window into that world. It's like our eyes, determining what we see and how we see it. Three.js provides different types of cameras, but the most commonly used is the perspective camera, and the one that we will use in our tutorials. This perspective camera simulates the way our eyes perceive the world, and it uses concepts like field of view, aspect ratio, and clipping planes that I will explain in detail in a moment. So there is this scene that holds all the 3D objects. We have the camera that are our eyes looking at the scene. Then we have the renderer, which makes possible to render and display what is in the scene in the canvas. Think of it, for example, the scene is my screen, the screen of my computer. I'm recording my screen with the camera, and then I have a renderer which helps to display my screen record to your computers. Now let's go back again to the camera to explain a few things. Look at this picture. I mentioned that the perspective camera uses concepts like field of view, aspect ratio, and clipping planes. Here you can see that this perspective camera will check several parameters. The field of view, which is this angle in the picture that determines how much of the scene is visible. You see this angle starting from the camera and going at both sides. That is the field of view. Then we have the aspect ratio, which is the ratio of the width to the height of the view, ensuring this scene looks proportional. Okay? Then we have this near clipping plane and far clipping plane. These define the range of distances from the camera within which objects are visible. For example, you can see that these two black objects are not visible because they are outside the clipping planes. By adjusting these parameters, we can control the camera's perspective and what is visible to our scene. So the field of view affects how wide or narrow the view is. The aspect ratio ensures the scene looks proportional. The near and the clipping planes determine the range of distances within which objects are rendered. Last thing I want to mention is the camera's viewing frustum is like this pyramid that you see from the camera to the far clipping plane. Let's see a picture of it. The camera's viewing frustum is the region of space that is visible to the camera. It's like a pyramid with the top cut off, defined by the field of view, aspect ratio, and clipping planes that we saw in our previous picture. Only objects within this frustum will be rendered, okay? So keep this in mind. Sometimes where you are debugging and not seeing objects in the scene, this might be a reason, so check it out. Next, we have the renderer. The renderer is responsible for taking the scene and the camera and rendering them onto a canvas element in the browser in our case, for our web application. Three.js provides the WebGL renderer, which leverages the power of WebGL to render 3D graphics efficiently. Because, as you might know, Three.js uses the power of WebGL. And that's it for these three main components: scene, camera, and the renderer. We have the mesh here at the bottom, which we explained briefly previously, that the mesh is a visible object in our 3D scene, consisting of a geometry, which is the shape, and a material, which is the appearance. Okay, remember this. The mesh consists of a geometry, which is the shape, and the material, which is the appearance, the look of it. We create meshes and add them to our scene to populate our 3D world. Instead of meshes, we can also add custom models, like in our case, we will add a 3D classroom model and also the teacher and other 3D models. But these are called primitive geometries. Let me show you some real examples of how camera works in Three.js. For example, see this, the comparison of the perspective and the orthographic camera. You see the difference? Here is like in the perspective camera, how the user sees the scene. And here is the orthographic. Okay. Let's see another example. Here we can tweak these parameters that we mentioned before, like field of view, the near clipping plane, and the far clipping plane, to understand how it works. For example, here we have the value of 45. Let's increase the field of view. You see, the field of view is that angle range that we saw in the picture. And the object must be inside this field of view. And let's try the near clipping plane. We cannot see here. So the near is best to keep it like 0.1 or 1. And the far is 100. We can also add the value of 1000 sometimes, so we make sure that we can see the whole scene. You see, if we decrease this value, we don't see anything because the objects are outside of this far clipping plane, as you saw in the diagram that I showed you previously. I hope it helps you understand better. Let's see another example. Here, take a look at the right window. You see, if I move this window at the left, you will see how it looks at the right with that field of view and that frustum. You see the frustum? The camera's viewing frustum that we talked about a while ago. And everything that we render is inside that frustum. That pyramid shaped with a top cut off. If I zoom in, you see the near. For example, I zoom in. You see this near clipping plane? Now I cannot see this cube because it's outside of this near clipping plane. If I go back, okay. The same if I zoom out a lot, you see this far clipping plane. You see, now the scene is outside of this far clipping plane. I'm sure that watching this is very easy to understand the concepts. Then while coding, is just an abstraction. Okay, I hope it helps. For any questions, you can always ask in the comments, and we can discuss even further. Now let's see how these concepts relate to React 3 Fiber. Take a look at this diagram. React 3 Fiber allows us to declaratively build Three.js scenes using React components. It abstracts away some of the complexity and provides a more intuitive way to work with Three.js. For example, take a look at the diagram. Here we use the canvas component as a container for our 3D scene. The canvas component automatically sets up the scene, the camera, and the renderer behind the scenes. We can think of it as a pre-configured environment where we can start building our 3D world. Inside the scene, as you can see, we have meshes and lights, which are the visible objects in our 3D world. The meshes are composed of geometries, which, as we said, is the shape, and the material, which, as we said, is the appearance, the look of the model. React 3 Fiber also provides the dry, as you can see in the diagram, which is a library containing useful utilities and abstractions. We used a lot of utilities from dry. So now you know that these components correspond to the equivalent Three.js classes, but with a more declarative and React-friendly syntax. For example, instead of manually creating a perspective camera instance, we can use the perspective camera component provided by React 3 Fiber. And we can set its properties like field of view, aspect ratio, near and far. Okay, so for example, aspect or near or far. Okay. You can also add settings of the camera here in the canvas component, like field of view, near and far, etc., etc. Similarly, we can create meshes using the mesh component and define their geometry and material using the geometry and material components, respectively. So, by leveraging the power of React's component-based architecture and the declarative nature of React 3 Fiber, we can build complex 3D scenes in a more modular and reusable way, as you can see yourself. That's it for now. And remember, the key takeaways are: the scene is our 3D universe. The camera is our window into that universe, our eyes. The renderer brings the scene and the camera together and renders them onto a canvas. The meshes are visible objects used in our scene, consisting of geometry, which is the shape, and material, which is the appearance. And React 3 Fiber provides a declarative way to build Three.js scenes using React components. These are the key takeaways that you should remember and understand. I hope this explanation helps you understand the fundamental components of Three.js and how React 3 Fiber simplifies this process of building 3D scenes. Okay, so since the 3D model of the classroom is ready to be downloaded, you can find the link in the description of this video or go to the repository on GitHub. Now let's create the 3D avatar of the teacher. I want to take a moment here to introduce you to an exciting platform called Avatar.me. And Avatar is a web-based tool that allows you to create personalized, realistic 3D avatars using just a selfie. These avatars can be used in a variety of applications, from marketing campaigns to games and metaverse experiences. What I really appreciate about Avatar is how user-friendly and accessible it is. the process of creating your own avatar is straightforward and fun. First, you just need to register on this website and verify your account. And to verify the account, you will be asked to verify it on their Discord server. Actually, I encountered a small issue with the Discord verification. I don't know why. Avatar also offers the verification directly on their website. So if you have problems verifying your account on their Discord, you can also use directly the website, as I did. Once you registered and verified, creating your avatar will be a breeze. Simply clicking here, a new avatar. Okay? As you can see, you have two options here. Use your camera or upload from device. And I suggest to use your camera because I experimented a bit with this and I found that using the camera I get the best result. But okay, if you have like very nice pictures of yourself, like not only in the front but also the left and the right side of your face, then maybe you can get a very good result too. But I suggest to use the camera. It's very straightforward. You will take 3 selfies, front, right and left. Okay? After posting these pictures of yourself, here you will have the option to customize your model. And let's take a look how cool it is. I have to say that the level of detail and realism in these avatars is truly impressive. You can customize various aspects of your avatar, such as body type, hair, clothes, sunglasses, and also you can add animations in the end. The resulting avatar looks incredibly lifelike and captures your unique appearance. Try it yourself. I, for example, chose this body type like I've been to gym the last months, because why not? Choose the hair here, or a hat if you like. There are nice clothes here for everyone. For example, this nice shirt. Okay, this one. Let's try this. Okay, this is like a Joker. Assassin's Creed. It's very fun to customize this 3D avatar. Headsets, because it's trendy now. Let's choose the shoes here. This one, or maybe this. And in the end, you can choose also the animations. This is one of the coolest features of Avatar, this ability to add animations to your avatar. You see, you have many animations you can choose from. Okay, like smoking a cigarette, I think. So when you are happy with your creation, simply click this download button and your avatar will be exported as a GLB file. This file is widely compatible with various 3D applications and is really optimized for the web, making it easy to integrate the avatar in our projects. In our case, we'll be using the downloaded GLB file and enhancing it further by adding other custom animations in Blender using Mixamo in this case. Mixamo has an extensive library of animations available there, and they are free to download. I'm excited to see what unique and expressive avatars you will be able to create. But now let's go and open Blender. I think you had no problem downloading and installing Blender. Blender is free and open source and will always be. And we should really appreciate that this tool, which is one of the best tools out there, is free and open source. My favorite tools are Three.js, Unity, and Blender. So I am a Blender fanboy. Anyway, let's delete this default cube as everybody does each time they open Blender. Where do these poor cubes end up after they are deleted? So here in this window, collection, delete hierarchy. Okay, we deleted everything. Now let's import our model that we downloaded from Avatar. So here, up at the left, file, import, then GLTF 2.0. Go to the folder where you have the downloaded file, downloads, and here model.glb. You see, now we imported our avatar. It's gray now because you should click here, this icon, viewport shading. Okay, now you can see. Now, let's go to mixamo.com and let's download the custom animation so that we can add it to our avatar. So visit mixamo.com, register and log in to this platform. And here, to be able to download custom animations to add it to our avatar, we need a character that has the same skeleton as our character. I mean, we need to upload a model that will have the same skeleton as our avatar. Because if you upload your 3D model of the avatar, you may end up in issues and we don't want that. So for that, I have ready to be downloaded, check the description links and download that file, which is called Mixamo something blah blah blah. So download that file, okay, and then upload it here where it says upload character. So upload character. As you see, it accepts only these types FBX, OBJ, and zip. Select character file. Go to the downloaded Mixamo mesh that I put it in the description. I should have it here. Okay, in downloads file. Okay, this mesh for Mixamo and upload it here. Let's wait a few seconds. Okay, it's ready. Okay, check if it's everything all right. We don't see any issues, so next. Your 3D character, blah, blah, blah. Okay, now we have this character here, and we want to add some custom animations. Let's search, for example, idle. I don't want this fight idle. Okay, maybe this one, simple one. Okay, maybe the position like he stands, I don't like it, but let's try this one. Okay, this one. Here, after choosing the animation that you want, download it. And here in these settings, without skin. So skin, without skin, frames per second, let's make it 60. And this keyframe reduction now, as it is, okay? It will be a FBX format, download. Do this with the other animations. So download, for example, I don't know, walk, to make our teacher walk. No, not this walking. Maybe, I don't know, this one. Okay, this looks okay. Download also this one. You have some other settings here like mirror, or you can play with these settings. So again, without skin, 60 frames per second. Download. After downloading all the animations that you need, let's go back to Blender. Now back to Blender. The first thing, let's rename this armature to Emilian, for example, or the name of your avatar. Then let's import our animations that we downloaded from mixamo.com. So file, import, and FBX, because they are FBX files. Navigate to the folder that you had the files, and let's start with the idle. Here you can see this armature _1 is the new animation that we added to the scene. Now select your avatar here, and then at the bottom, at this editor type button, click it and select this dop sheet. Enlarge it, and here you should choose the action editor. And here in the middle of this window, you see this button here where it says browse action to be linked. Click on this and you will see the animations that are associated with your avatar. I have two here because this other idle v4 blah 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 is the animation idle that I exported with my avatar from Avatar. Because on Avatar, remember, I selected an animation. And when I downloaded it, there are several options there. Download with animations or download for Blender, etc., etc. I downloaded with animations. So this one is from Avatar. This is the new one that we downloaded from Mixamo. So select the new animation that you have here and change this name to something that makes sense. In this case, idle. If you press the space key, it will play this idle animation. You cannot see it, maybe because it's an idle animation. So he is not moving a lot, but it's there. Press the space key again and it will stop. Now, we want to add other animations. And for that, here, in this editor type, choose this nonlinear animations. As you can see here, in this Emilian, which is our avatar, we have these two animations associated with it. The idle, the new one from Mixamo, and the one from Avatar. Okay? To add a new one, click this button here, an arrow down, like push down action. Click it, and we added a new strip here. After adding this new strip, we can delete this animation that we imported in the scene. So delete hierarchy. Now we can import the new animation, import FBX, then this, for example, thankful. We have it here. Here, where you see this armature _1, which is the new animation, change the name again to something that makes sense. And it was thanks. Here, where it says no action, here at the right, where browse action to be linked button is, choose the thanks. Okay? Now you can see the thanks is here. If you press the space key, you will see the animation playing. So to add another animation, the same process again. Click this push down action button. Then you can delete this animation here. And again, import a new one. Import FBX walking. Okay, this walking animations seems to have some issues, but doesn't matter. The same process here. Change the name, walk. Then here where is no action, click the button here at the right and choose walk. Now you have it. You can play it. It will walk with some small issues, but doesn't matter. It works. The same process if you want other animations. Click this button here, push down action, delete the animation here, and import FBX, etc. After you are happy with the animations that you want for this avatar, let's export it in a GLB GLTF format, which is optimized for the web. So File, Export, GLTF 2.0. This is red because I think I have another file with that avatar, so just new avatar. Okay, I downloaded this. Now let's go back to our application and let's use this new avatar. Let's continue with our tutorial. We will get back to code and add our 3D models instead of the box geometry. We have two 3D models at the moment, the 3D classroom and the 3D AI teacher that we made with Avatar, Blender, and Mixamo for the animations. Let's get back to code. So I have imported the models here in the public folder, public modules, and we have this classroom GLB and avatar GLB. To import them into the Three.js scene, it's very easy. The first solution is very easy. So delete this box. And here, let's import this GLTF component from React 3.js. And here, let's add an attribute src and insert the path of the models. So for that, when it's in the public folder with void, you just type / models, so you don't need to add the public models, and then classroom.glb. So we imported this GLTF from React to Dry, and this component makes possible to load the GLTF files or GLB, which are basically the same thing. Here I will add some other properties like position and rotation, so we make sure that the classroom displays correctly, because I tested this and I know the exact values that the classroom will display correctly, because sometimes you might have, I don't know, the model has a scale is too small or it's too big or the position is not correct. So you should play with these values if you see problems in the scene. So for the position, you open these curly brackets. Okay, so when you open the curly brackets in React, you can put a JavaScript code, because to put JavaScript code in this HTML-like syntax, which JSX is, you put these curly brackets, okay? And to add the values of the position, the values are 3 values for X, Y, and Z. So we need an array for that to add 3 values. So array, and then for x 0, for the y -8, which I found out was correct for me, and for the z 0. Similarly for the rotation. So rotation, curly brackets, we need an array for the 3 values for the x 0, the y, in this case I want 180 degrees or half a circle. So I want to turn back that classroom because when I first loaded it, it was in a wrong direction. So I want to turn and rotate 180 degrees, or math.py. Okay? And for the z, 0. So math.py is 180 degrees or half a circle. You know, pi is the mathematical constant. You already know that. So math.py is equal to 180 degrees. If you want a full rotation, you'd need math.py times 2. Or if you need 90 degrees, you do math.py divided by 2. So it's not lowercase, but it's uppercase. Let's take a look in the browser if we see something. So are we correctly? Okay, we are importing the environment into the app component. So it should display correctly. Let's check. Okay, yes, it displays correctly. You can see the classroom. It looks nice. The position is correct. The rotation is correct. So it works. And we have our 3D classroom. That's it. It's easy, right? Easier than this? I don't know. Now, let's do the same thing for the teacher model. So copy this down below, change the path. So it's a million dash avatar.glb. And let's change the position and the rotation. But I will also add the scale here because I found out that the scale wasn't correct. So scale 777 for the 3 axes and this position and rotation values. Okay, copy them and let's check it out. Okay, we see now the teacher, which is my persona. And we can zoom and rotate and explore. And this is because of the orbit controls. The orbit controls make possible to navigate and explore the 3D scene. Okay, but maybe we will fix this, that I don't want to zoom out after a certain point and I don't want to zoom in after a certain point. Okay, we can fix that part. For now, everything works. We are rendering the scenes and it looks good. Maybe we will adjust the lights. Okay, we need better lighting. So let's do that first. So here we have the light, the ambient light. If we hide this light, we will not see anything in the scene. You see, it's dark. Let's turn back the lights. Here, let's add the intensity to 0.8. It should be enough. Okay, again, these S-lint errors, I will disable them. Copy this. Go to S-lint file, here. Off. Okay. Because yeah, slint does not recognize this property intensity. And let's add the color for the light, and let's make it white. Let's see the changes. Not so much of a difference, to be honest, but we can do better. We can do better. All right, let's dive into the world of lighting in Three.js and React 3 Fiber. Lighting plays a crucial role in creating realistic and visually appealing 3D scenes. It can set the mood, highlight important objects, and provide depth to your scene. First, let's talk about the different types of lights available in Three.js. Let's start from the first one, the ambient light, which is the one that you are seeing here in the scene. And ambient light is a basic light that illuminates all objects in the scene equally from all directions. Okay, so it's not from one direction, it's from all directions. It doesn't have a specific source or direction that I mentioned, and it doesn't cast shadows. Think of it as a global light that provides a base level of illumination to your scene. For example, we can tweak the parameters here just to see. We have two properties of the light, the intensity and the color. Let's try. Let's make it red or green and so on. So it doesn't look much like real lighting, you know. It's like adding color to the scene, but it doesn't really look like lighting. So that's why it's not the most useful lighting. Okay? Let's introduce another light, which is the directional light, which is the one that you are seeing in the scene right now. The directional light simulates a distant light source, such as the sun, that emits light in a specific direction, in this case, not like ambient light. It illuminates all objects in the scene from the same direction, as if the light rays were parallel. Directional light is often used to create strong directional shadows. Let's play a bit with the properties here. You can see we have color and intensity like with the ambient light, but here we have additionally this X, Y, and Z directions of the light rays. So if we play with it, you see the lights and the shadows changes in the Z axis and in the Y axis. You can add directional lighting, the same as with ambient light. Create a component here, directional light. We add the intensity like the same with ambient light, but we can also cast shadows. Ambient light doesn't cast shadows. And also we can add this position for the X, Y, and Z. Okay. Then we have the point light. The point light represents a light source that emits light in all directions from a single point, like a light bulb. The intensity of the light diminishes with distance, creating a realistic fall-off effect. Let's try it here in the scene. We have the color, also the intensity, and the distance. You see this effect based on the distance. And we can change also the direction for the X. The Y up above and the Z for the depth. Okay? And you can add the point light the same way. So point light component here, it casts shadows, it has the intensity and also the position. So these are the main lights, the most used, but you also have the hemisphere light and the rect area light. But if you want to know more about these other two lights, you can check the documentation. Because right now I want to introduce you to another way of lighting, and that is the environment lighting that we get with a component named environment from Dry. Let's try it. So we import environment from Dry. Okay, add it here. We have this conflict of naming. I should rename it this environment. It's my fault. So environment component. Change it here in the app component as well. And let's use this environment. The environment component in Dry is a convenient way to add environment lighting and reflections to your scene. It creates a background environment that can simulate realistic lighting conditions and also reflections on the objects. Environment maps are 360 degrees images that capture the lighting and reflections of a real-world environment. They provide a realistic and immersive lighting setup for your scene, and you will see it yourself right now with our classroom. Okay, so you import it here from Dry and then use it here simply as a component, and that's it. And we can use a preset for it. So preset, we have city and other presets. You can check on Google for the other presets of the environment, but let's choose this environment preset city. And also we can add a color. For example, white. Let's check our scene. You see the changes? It looks better now. We will add the intensity and also maybe change the color of the light. Or we can use the intensity of this ambient light. So the ambient light has this intensity, color white, and let's see now the difference. Yes, much better. I should change the color of this ambient light, actually. For example, red. You see a red room. Pink. A nicer look. Let's search environment light presets Dry. Let's ask the copilot. So the presets are these like sunset, dawn, night, warehouse, city, forest, apartment. Let's try some of them. So forest, but we are not in a forest, so okay, but just to try out. Forest. It has like a greenish color, but it looks good actually on our classroom. Because we have this a bit of greenish. I like it, but we have the pink color for the ambient light. So we have like a mix, okay? But let's try the others, I'm curious. So dawn, night and sunset. Let's try the dawn. Ooh, it's a bit too bright. We can lower the ambient light, but it's a bit too bright. Yeah, okay, it's like the morning, early morning. Okay, let's leave this one. So the classroom and the teacher looks good. The lighting is nice. The next step would be to change this T-pose of our avatar and add an animation. And we have the animation idle. So the teacher will play the idle animation and not stay in this T-pose, because this is like a default pose for the avatars. To play like an idle animation, we will play the animation that we imported from Mixamo. And later, with some interactivity, when we click, we can play another animation. But before adding the animation, I want to show another way to load these 3D models, because the way that we are doing right now with the GLTF component, it's very simple, but we might want to try another way, because these models are GLB file, and we want to manipulate this later. For example, we want to get the animations, or we want to get the materials, we want to get the nodes, etc. So we need to loop or traverse through the properties of this GLB file. And the best would be if we have like a component, like a React component for this GLB. It would be the best, and we can do that. We can convert this GLB file into a declarative JSX component. Okay? How and what it actually means, we will see it together now. Now in this component, I'm going to explain line by line everything, each line of code. Starting at the top, we import the dependencies that we need for this component. What are important here are these useRef, useGLTF, useAnimations, which are called hooks in React. So let's talk about these hooks. After taking a quick look at the component, which is a function component named model, we can rename it later into something that makes more sense, like avatar or anything. We accept props, and then we return this group, which is nothing else but our 3D avatar. So let's explain these hooks, what they are, and so we can go line by line and explain everything else. In React, hooks are like special superpowers that let you add extra abilities to your components. And they hook into different parts of your components. They always start with the word use. Use ref, use GLTF, use animations, and later we will explore very important ones like use effect and use state. I'm going to explain them when we are there. So these hooks help you manage different parts of your component, like keeping track of these values or to load the 3D models in this case. And to dive into the specific hooks, let's start with the useRef here that we create at the beginning. We define a group variable and assign it to this useRef. A useRef is like a special container that can hold a value. It's super helpful when you need to track of something that might change over time. We want to get a reference to the root group. The root group is this one here, the root group of our 3D model. So we want to get a reference to this Y because we might need later to use this reference to do things with this 3D model. Okay, so we define this group variable equal to useRef, and then we add the attribute ref to group to this one. So now we have the reference to this root group. That's it for now. For now, all you need to know is that this useRef hook holds a reference to the main group of our 3D model. Later, we can easily access and modify the main group whenever we need, even if our component updates. Okay, that's it for the useRef. Later, you will have other uses with useRef, but for now, you just need to understand this. This useRef hook is to hold the reference to our root group of our 3D model. Then we destructure these nodes, materials, animations from this use GLTF hook that loads our object from the public folder. Use GLTF is like a magic function that helps us load the 3D model into our component. We give the path and then it will load all the necessary information. In this case, the nodes, which are the individual meshes, and we talked about meshes, what they are, the shapes, which are the geometries, and the materials, which are the appearance, and the animations that we know what animations are. So this line here, const nodes materials animations inside the curly brackets equal to use GLTF, means nothing else than unpacking all this important stuff from the loaded model to give us easy access to them. Okay, so the structure unpacking all this important stuff from the loaded 3D model. Now we have another hook, use animations, from which we are destructuring actions and mixer. This is another useful function that helps us work with the animations of our model. We use it by writing the same way, const actions mixer. We unpack them from this use animations hook. It will give us these tools. That's it. The actions are like individual animation clips, and we can use them to play specific animations whenever we want. So actions are individual animation clips. The mixer is like a puppet master that controls how these animations play and to make sure that all works together smoothly. So we will use this mixer to control the animations, to play them whenever we want. That's it for the hooks. Here we return this whole group, and let's talk about the group element in our component. In a 3D world, a group is like a container that holds multiple objects together. It's like the box where you can put different things inside and move them around as one unit. So in 3D world, a group is a container, a box. We can put different things inside and then carry with us as one unit. Groups are super helpful when you want to organize and control related objects together. For example, you can move, rotate, or resize a group, and everything inside it will follow along. This is why we need them, because everything inside the child of the group will follow along if we do something with this group. So if we move the group, rotate or resize, everything inside will follow along. So in our component, we use the group elements to structure the model in a neat way. Like building a house. We start with a main group, let's say the foundation of the house, and then we add smaller groups inside, that are the rooms, for example, inside our house. Then we have this skinned mesh. And we mentioned where meshes are, but why they are called skinned mesh and not simple mesh. First, we need this skin mesh inside the groups for the reason because by wrapping the skinned mesh elements inside this group, we can easily position, rotate, and scale the entire avatar as one unit. A skinned mesh is a special type of object that represents a part of the character or the creator or whatever it is in a 3D model. Unlike regular objects that are static and cannot change shape, a skinned mesh is like a stretchy, bendable action figure. So it can move, it can deform based on the skeleton that has inside it. And the skeleton is like the bones. We have the bones, and the 3D model has this skeleton. So we use the skinned mesh elements to represent different parts of our avatar. In this case, the different parts are, as you can see, avatar and body. Avatar is from the platform. So body, hair, look, and shoes, or legs, arms, head, and other parts. And inside, each skinned mesh has a specific shape, which we said that is the geometry, a specific color, and texture, which is the material. And also a skeleton that defines how it can move and bend. Okay? We saw that when we imported animations from Mixamo. And that's it. We use this skinned mesh to create the animated avatar. Okay, I think I mentioned everything here. I can also mention the props and the dispose null. So here we use this 3-dot props. This is the spread operator. Maybe I should not go and explain the spread operator here. I am sure most of you already know, but there are also absolute beginners. I know that. So you should check the documentation and understand what the spread operator is. Okay? Because it's a concept in JavaScript, pure JavaScript. It's not Three.js or React. Okay? It's simple JavaScript. But basically, what it means is nothing else than we spread the properties object to pass any additional properties to this group. So with this props here, we pass any additional properties to this group. That's it. Then for the dispose equal null, this is another prop that is set to null to prevent the model from being disposed when the component unmounts. The component unmounts is a life cycle of the component. The component firstly it mounts, okay, and then we can also unmount the component when we don't need it. So it mounts and also unmounts. So to prevent this model from being disposed when a component unmounts, we use this dispose null. Sometimes you use this dispose to dispose 3D objects that you don't need anymore, to not load too much of the scene. And sometimes you don't need to use the dispose because it can also be expensive. For example, create and remove, create and remove. It can be expensive. When you want to remove an object, for example, sometimes you do other tricks like make it invisible by setting its materials to invisible, or also turn the lights off, for example. So other tricks that we might learn later, maybe. But we are doing simply this, dispose null, because we want to prevent the model from being disposed. Okay, there is also this primitive object nodes.hips. We have this primitive component that represents the hips, in this case, the hips node of the 3D model. Now, this is typically the root bone of the skeleton hierarchy, and it's used for positioning and animating the entire avatar. Okay, so this is the root bone of the skeleton hierarchy. Okay, that's it for now. I hope you understand everything now inside this component, or at least you have a general idea how this is made, because we transform a GLB file, which is unreadable, into a declarative React component. And we can use it as a normal React component everywhere. So it's reusable and maintainable. Okay, now let's fix and import this new component to our environment. So rename it from model to avatar. But first, we should do something here. Change this path directly, and we will add a variable for that. So path model, and here import path model from models dash avatar.glb. Also here in the preload path model. If you have errors in your browser after adding this new component, you should add a line of code here in the void config.js, which is assets include this GLB. Because void doesn't know by default what a GLB file is, and with this you just tell void, I don't want errors because I know this is a GLB file. Okay, just read it. So in case you have errors, include this assets include blah blah blah. So we renamed the component avatar. We changed here the path to a variable, because also when we deploy GLB here, okay, typo, because when we will deploy the project live, we need to do this to not have errors later. So in environment component, by the way, let's also change the name here. Let's remove this GLTF and import avatar. Import avatar from the public folder, because we have this in the public models folder. Here I need the position, so I'm going to copy that, remove the GLTF, add this position, rotation, and scale. We should not have any error, and let's check. Okay, everything seems to be fine, no issues. Let's check the console log, nothing. Okay, everything is correct. Now we understood why we did that and why is it much better to have a JSX component instead of using the GLB. We can do the same thing for the classroom. So let's go inside the folder. I should be there, pvd, okay, I'm there. So mpx gltf JSX, the name of the file, so classroom.glb. And we created this component. It's the same thing, you see, we import this use GLTF and we return this group, which is the classroom, and unpack nodes and materials from use GLTF. Let's do the same thing, remove here the path and add a variable, path model, and also in the end, in the preload, we are good to go. You see, it's the same thing. Here we don't have skinned mesh, but we have mesh. If you need to manipulate one of these meshes, for example, let's say this is the blackboard, you manipulate here. You can also attach an event listener to it, like an on-click event, for example. I want to click that element inside the classroom and do something with it, an animation, or I don't know, change the color or change the texture. You can do anything. So this is why it's very useful. So you can target individual meshes inside this 3D object, which is the classroom, and manipulate them, add event listeners, or do anything. Okay, so we refactored the code. We can continue to the next step. Alright, let's continue our tutorial by adding an idle animation to our avatar, so it doesn't stay in the T-pose. We'll use the use effect hook to achieve this. I mentioned it before, and I'll explain what use effect is. So first, import this use effect here. It's from React, so use effect from React. Here I have a snippet, so use effect snippet will delete what's inside. So it's basically this. What a use effect is? We see it's like a function that returns this callback, and we have this array here, which is a dependency. What's happening here? Use effect is a hook that allows you to perform side effects in your component. Side effects are things that happen outside of your component. Anything that is outside, like for example, in our case, setting up animations, so outside of our component, or fetching data from the internet, or even cleaning up when your component is no longer needed. So these are side effects. And how this use effect works? The use effect hook takes two arguments. A function that contains the side effect code. This is where we define what we want to happen when the effect runs, and an optional array of dependencies. This one here. This is the array of dependencies. The effect will only run when one of the dependencies changes. And here we usually pass a variable, okay? For example, like actions in this case here. So the effect will only run when one of these dependencies changes, because we might have other dependencies here, okay? Dependency 2, 3, etc., okay? But what if I don't put any dependency here? I leave it empty. In that case, if you omit the dependency array, the effect will run after every render, okay? So if you leave this empty, it will run after every render. If something triggers the render, it will run after every render. Or if we put a dependency here, it will run every time that changes, like for example the animations. Let's explore in more detail. The first part is the side effect function. So this one. This is where we define the code that will perform the side effect we said. The functions will run after every render of our component unless we specify dependencies here. We specified a dependency. Otherwise, it will run every render. We can think of it as a place to set things up, or a place to make things happen in your component, okay? So this is the place to make things happen. The second part is the dependency array. This dependency array is the second argument we pass to the use effect, okay? Because you see these brackets here. The first argument is the function that we talked about, and the second argument, this is a comma here, and the second argument is this dependency array. So this use effect has two arguments. These are the two arguments of the use effect. And we said that the dependency array is an optional array that specifies the dependencies for your effect. In our case, animations, etc. If we include variables, props, or state in this dependency array, the effect will only run when one of these dependencies changes. So if this changes, it will run. Otherwise, it will run on every render. Okay, and that's it. Now, let's write the code to play our animation. And that is very, very easy. I don't know if it can be easier than that. Because you might think, oh, to play the animation, we should write a very difficult code. No, it's very, very simple. It can get hard if we have some complex animations or animation sequences, or we play these animations based on states, specific states, etc. But in this case, just to play the idle, it will be very straightforward. And there are many methods to do that. Some are harder to understand as a syntax, and others are very simple, like the one that I will write. So, to run the animation, first we need to know what's the name of that animation. We really don't know what's the name. Okay, maybe I know it's idle, but we don't know. We should inspect. Okay, in this case, we simply console log the animations. So console log animations and pass the animations that we unpack from the use GLTF that we mentioned at the beginning, remember? So let's check the console. Here we have animations and all these animation clips like fight, grid, look around, running, thanks, think, and walking. Okay, so what we need is for the idle is this the only name that is confusing. So let's copy it, but we can also try this fight or grid. So the first thing, I need the use effect. And the way to play this animation is straightforward and very, very simple. Because you may think that the code would be very hard to write for playing animations in Three.js, but actually it's not. It's very, very easy. It may be hard if there are complex animations, or if there are, let's say, a sequence of animations, or if the animations are based in some interactivities or based in React states. So it may be hard in those cases, but just to play this idle animation to test it, it's very easy. So I will create an if statement. So if there is this animation with this name, for example, the grid, play it, and that's it. So if condition, the condition is if actions open array string grid. So if this is true, if I find the grid animation in the actions array, okay, then play the animation. So action dot play or animation dot play to give it a name that makes more sense. But we don't have this defined, of course, because this will be const animation equal to this one, this animation that we find. Okay, that's it, really. And we pass here the actions, so every time the actions, so the animation changes, React will re-render. It's really that easy. So if actions grid, if this is true, if we find this animation with this name grid, animation.play, we just define this animation here, assign it to the specific animation, which is actions grid. And it should work. We can test it. Okay, it's not working. Why? Weird. Let me go back to the code. It should be a stupid error, I know. Okay, I saw the bug. Here, animation.play, this is a method. So, parentheses, to call this method. So, it will play. I think it should be okay now. Let's check. Yeah, it works. The animation is playing. You see, it's the grid animation. So you can add the other names there in the array to play the animation that you want. For example, the idle, but since the idle had like a long, confusing name, I just played this, the grid animation. For now, it is played on loop, but we can make it stop, play it just one time or as we wish. Okay, so this is for the animation. Maybe later we can add interactivity and play the animation based on an event, or I don't know, play a sequence of animations when we click something. So we will explore things later, or in another version of the application. Maybe not in this tutorial, but in another one. I don't know. We will see. Okay, let's continue by diving into something really exciting and highly requested, which is integrating a chatbot using the OpenAI API. So we will add ChatGPT to our application. First, let's talk about what we are going to achieve here. We want to add the chat component that allows users to interact with an AI-powered teacher. So the users will be able to ask questions and the teacher will provide responses using the power of OpenAI's language model, so the ChatGPT. To get started, let's create a new component called chat and add it in our project. This component will handle the user input, send request to the OpenAI API, and then display the teacher's responses. Now, I created this folder inside the components chat, which has the chat styles. You don't need to write all these styles. I did it for you, so you have it ready. We will go step by step instead with a component, of course. Here we need two imports. We need the useState hook from React to manage the state of our chat component, and we need Axios. Axios is to make HTTP requests to our server, because yes, we are also going to build a server. So this is not just a front-end application, okay? We will build a server with Express.js. Let's import useState and Axios. First of all, you need to install Axios with npm i Axios. Okay. And the useState, we already have it from React, so I don't need this React here, but useState from React. And Axios is import Axios from Axios. Now let's define our chat component. First of all, we need some state variables, okay? I will explain what state variables are, what is useState, and everything. But first, let me introduce you with the syntax of these useState and state variables. So without explaining it first, I will just introduce you to these useState and state variables. So you just get a bit familiar with it, and maybe with intuition you will understand it without explaining it. But then we will go and explain it in detail, okay? What we need for this chat component? What I need to handle the user input, because if you think about it, okay, I want to make this chat component. What would I need for this? We need a chat box, okay? So it will be like an input form. So we need to handle this user input. So we need a state variable for that. Everything that changes in our application, we need a state variable for that. In this case, the input from the user. To create these state variables here at the top level of the component, not inside the return statement, but at the top level, I have a snippets for that. So I write down state, useState. I have this useState snippet. And you see, I click it. I have it ready. First, set first. Change it without touching anything else. I just write down the name. So user input, it will change both of them. And then press the tab, it will go here, which is the first value of the useState. So I will leave it empty. So an empty string, an empty value. If you don't know what is this extension for these snippets, okay, the guys that are experts, don't laugh at me, because I also teach these basics things, because we have absolute beginners here. So why not explain to them, because they may get confused. So we don't want that, because when you get confused, you get frustrated, you lose the patience. When you lose the patience, then you might lose also the passion, and so on. So we want to make things comprehensive, okay? I have this extension. I can show you. I don't remember the name, but we can find it. It's React something, React snippet or something like that. Okay, is this one. This ES7 plus React Redux React Native snippet. Okay, this one. search for it here in the extensions tab and install it. Reload the VS Code and you are good to go. Because yeah, it's useful. We have our first state variable. So let's ask again ourselves, what do we need for this chat component? Maybe if you don't know it yet, you can continue and build the chat component, but you should think first, what do we need? We need this user input from the user, of course. Since we need this user input and we have this user input, we will need also the response. So the response is from the teacher. In this case, our 3D avatar, which it's me. And the teacher will get this response from ChatGPT, okay, from OpenAI's API. So not only the user input, but we also need a response. Let's create another state variable. So using a snippet, teacher response. Let's call it teacher response. Also the initial value, because you understand it, that this is the initial value. I say you understand it because, yeah, a bit intuitive. As I mentioned before, this is the initial value. And leave it empty. Okay? We will go in detail explaining this, no worries. What else we might need? At the moment, we are good to continue. But if we think of it, I also need to, because this chat box will not be all the time showing in our screen, because I want to show the beautiful 3D classroom, okay? I want to have a button here like ask a question, and when I click that button, ask a question, I want to open this input form. I don't want it all the time visible in my screen because it will block the view of 3D classroom. So I just small button at the top, maybe at the left, click in that button, ask a question, it will open the chat box. Then we can write down the command, send it, and then we will get the teacher response from ChatGPT. Then we can close that, so it will not show. So for this, if you think of it with this logic of React, we need this chat box, but we will not use it all the time. So only when we click the button. So we need the state variable show input or not show input. So let's add another state variable. This is a Boolean, by the way, true or false. Boolean are true or false. Snippets, show input, and the initial value will be in this case not an empty string because this is a Boolean, but true or false. And initially it will be false because initially we will not show this chat box. Okay, so you get the idea of building a React application. I don't want to show just follow me and I'm writing down, I'm writing this, I'm writing that, look at me, how good I am at coding. I'm not that good, actually, to be honest. I just research things and step by step I also build these things because I make errors and bugs and a lot of them. So I also want you to go through this, okay? Because I really don't like spoon-feeding tutorials. For me, it's not really the best way to learn. The best way to learn is doing yourself. So not every tutorial is useless, but if you go with the tutorial and stop the tutorial, for example, in this case, stop the tutorial and try to understand it yourself, what you are doing, without just listening and copy and pasting, okay? But also ask questions. Why do I need this user input? Why Emilian is defining this user input? Also for the teacher response, etc. And you can imagine how you will structure yourself and how you will build it yourself. Okay, maybe you don't know how to do it right now, but okay, having just like a picture, I will create an input form, and in this input form, we will add maybe an event handler to handle the input, etc., etc., etc. And maybe the last state variable, at least at this initial stage, I need a loader because, as I said, before we show this chat box to waiting for the data, I want to show something, so a loader, okay? Based on that loader, showing the data or not. When the data is not ready, I will use this is loading or not. It's again a boolean, true or false. Snippet and is loading, stat is loading. I wonder if my English sucks. I don't know. I think I don't speak it very fluently, but okay. Peace, guys, because it's not my native language. So I try very hard. I speak fluently Italian actually. Italian is like as my mother language, Albanian, but I'm trying to practice with English with these tutorials because only when I speak with my colleagues remotely, but yeah, you know, it's not like the same when living in a country with English speaking people, okay? Or if you have friends that speaks English or a girlfriend, etc., etc. But let's not talk about that, okay? No. Here it's a boolean as said, and initially it will be false. We have these state variables, and by now we are good to go. Let's continue by explaining what this useState really is and what state variables are. Why we need a useState, why we need these state variables, what's happening with them, and all the other details or questions that you might have. Again, this is for the guys that are absolute beginners, the other experts that are following me, and I know they get a bit bored from this, and they don't follow me anymore when I explain these things step by step, but I have the absolute beginners in mind. Okay, so bear with me, please. Okay, I'll do my best to explain it in a clear and comprehensive way what the useState is. Imagine you are building a toy, like a car, for example, or imagine you have this car in a video game. Okay, imagine you want to build a game like a rally or racing car. Okay, and let's focus just in the car. The car has different properties like a color, black or white or red. The car has a speed, whether it's currently running or not. It's also another property of the car. And all these properties can change over time based on how you play with the car in your game. Okay, is it clear? In React, we call this changing properties state. So again, I will repeat it. In React, we call this changing properties state. Now, let's say you want to keep track of the car's speed, or let's say of the car's color. You don't have the tools like JavaScript or React. You just have a piece of paper and a pen. So to keep track of the car's speed and the car's color, you just have a piece of paper and you might write it down, the initial color and the initial speed of this car. So write down in the piece of paper, car's color, red, okay? Car's speed, I don't know, 50 kilometers per hour. And then whenever you change the color or the speed of the car, you update the values on that piece of paper. So again, below, you update the car's color, it changed, equal black. The car speed, it changed, equal 100 kilometers per hour. This way, you always have a record of the current state of the car. The current state of the car is the last one that you wrote on your piece of paper. So in React, we use the useState hook to create and manage these state variables, just like that you did in your piece of paper. The useState hook is a special function provided by React that allows us to add the state to our component. That's it. We showed here how we did that with a code that I told you that to be familiar. So const, then we open an array, user input, and set user input equal to useState with an initial value of an empty string. So we are basically here destructuring this user input and set user input from this function useState. We are unpacking, if you don't like the word destructure. So I unpack these two variables, user input and set user input. But let's break it down in detail. We declare a state variable called user input. This is called user input. And we also declare a function to update this, and it is called set user input. Also the name, it's intuitive, set this user input. So that is a function. The useState hook takes an initial value as an argument, as you see, which is this empty string. It's just an initial value because we need an initial value when we load the first time the application. For example, the boolean will be first false. That teacher response will be false because we don't have a teacher response. The user input will be an empty string because there's nothing initially, okay? The useState hook returns an array with two elements. Again, I will repeat it so it will stick in your mind. The useState hook returns an array with two elements, the current value of the state variable, which is the user input. So this is the current value, and the function to update it. Okay, I will not repeat it again. That's it. But remember, it is called array destructuring, this thing, to assign these two elements to separate variables. It is called array destructuring. So we assign two elements to separate variables from useState. Okay? Unpacking, destructuring. As a beginner, I always ask these dumb questions, but no question is dumb. Why do we need state variables? So teacher, raise your hand and ask the question. Why do we need state variables? Okay, let's ask the 3D teacher from ChatGPT. And the 3D teacher from ChatGPT will give this response. Well, just like the car in our video game, just like the car's color and the car's speed might change in time, our data in React components can change over time. State variables allows us to store and manage this changing data. That is the reason why we need these state variables, to store and to manage the changing data. So this is the reason we have all the state variables. And since we have an initial value, then later, whenever we want to update this value of the state variable, we will use the corresponding setter function, which is this, the second one. This set user input, set teacher response, etc. This is called the setter function. So we will call this setter function to update the current state. React will then re-render the component with the updated state value. Okay? We call the set function to update the state variable, the current state. Then React will re-render with the updated state value. But another question, why can't we just update the state variable directly? Like user input equal new value. User input equal new value. Why not? React relies on the setter functions to keep track of state changes and to trigger re-renders efficiently. So by using the setter functions, React knows exactly when and how to update the component. Okay? That is why. Using these variables with the useState hook, it will allow us to create this dynamic and interactive component. And that is why React is so powerful. We can then respond to our user input, update the UI based on data changes, and keep our components in sync with the latest data. Okay? This is the power of React, to keep our components in sync with the latest data. That's it for now. So please, if I completely bored you, just skip me in these sections, okay? Please bear with me. Now that we have this use state and variables, let's add some event handlers to manage user interactions. We need, first of all, an event handler for the input, okay? And let's call it handle user input. Always here at the top level, below the state variables, const handle. This is the convention. We use this handle and the name. So handle user input, okay? Arrow function. This is the first event handler. This handle user input, what is its function? What is the work that it should handle? It will update the user input, so the state, whenever the user types in the input field. So the user types in the input field, and this handler will update it. Okay? And how it will update it? We said that we call the setter when we want to update the current state. So call the setter, set user input. You just call it like this, open the parentheses. And with what value? With the value that the user types. And with what value? It will be the value that the user types. And how we get this input from the user, how we get it, how do we know what the user is typing in the input field? We get it by passing this event here, and then inside the setter function, event.target that value, and this is the value that the user is typing in the input field. So you might ask again, what it means? What is this event? How do we get it? How do we know? Like, how do things works? Okay, so let's break it to check what's inside, like we used to do when we were kids. I used to break things and just to check what's inside, and I broke many toys just to satisfy my curiosity. Okay, so let's break this function here. What's happening? How do I get this event? What is this event? Okay, and what it means, target. So let's break down and answer all the questions that a beginner might have. And maybe you also ask these questions in your mind. The first, what is an event handler? This function that we created. An event handler is a function that gets called whenever a specific event occurs. In our case, handle user input is an event handler that will be called whenever the user types something in the chat. This is what it is. Next question a beginner might have. What is this event argument here? So when an event handler is called, it automatically receives an event object as an argument. So when this is called, it automatically receives an event object. This is an object. This event object contains information about the event that triggered the handler. Because what triggered this? Okay, it will contain all the information about what triggered this handler. So we specified as the parameter here. This allows us to access the event object inside the function. Another question, where does the event object come from then? The event object is automatically provided by React when an event occurs. So when an event occurs, it will automatically be provided by React. It's created by the browser, and it contains all the useful information and the methods related to this specific event. For example, when the user types in an input field, a change event occurs. Okay, I type in the input field, a change event occurs. This is an event, and React passes the corresponding event object to the handler. So I type in the input field, a change event occurs, and React helps us to pass this corresponding event object with all the information to the event handler. Okay, I hope I am clear. Yeah, you have other questions, I know. Another is, what is this event.target? I understood that the event is the object that contains the information, but what is the event.target? The event.target refers to the DOM element that triggered the event. Okay, again, I will repeat it. Event.target refers to the DOM element, you know, the DOM, that tree-like structure with all the elements. The target represents the DOM element that triggered that event. This object provides access to the properties and methods of that DOM element. So that DOM element have properties and methods. I access this event.target and I will access properties and also methods to allow us to interact with the element and retrieve the value, because I want to retrieve the value, and you get this event.target that value. So you might ask again, what is event.target that value? Okay, I know you are bored, I know. Event.target that value specifically refers to the current value of the input field. So this is what we want. We wanted the current value of the input field to set our state, because our state is the current value of that, what the user is typing. And then we change into the current value. That becomes the current value. We type something else that we change and that becomes our current value, and so on. Okay, if you type this in the console log, you will see every character, what we type, it will become our current state, because we said that we update the changes with the setter function. Okay, any other questions? I don't know, like how do we use this event.target.value? We use it like this. In this function, handler user input, we call this set user input, and we pass as an argument event.target.value, which sets the value of our user input state to whatever the user has typed. So it will set this value, the value of the user input, to whatever the user has typed. By updating this user input state variable, we are storing the user's input and making it available for further use in our component, such as sending it to the OpenAI API. Okay, that is a reason that we want to store it, to send it to the OpenAI API. I don't know, maybe the last question, how do we connect the event handler to the input field? How do we connect this? That is a good question, and we will do it next, when we will create the code inside this return statement. We will create an input element, and then we will pass these values to the input and connect the state with the input field. Okay, we are going to do that next. And let's add another event handler, which is the toggle input, to toggle the input. Okay, and here to toggle the visibility of the input when the user clicks the button ask a question, or when closes this chat box, we will call the setter, in this case set show input, and here we'll add this exclamation mark and set show input. What this exclamation mark means here, this is called the logical not operator. If you have a Boolean variable, in this case, like we have this show input. Why I have this set show input? Okay, this is a typo. It's show input, set show input. I made a typo. Okay, so this is a boolean, true or false. And we use this logical not operator. If you have a boolean variable which is true, it will evaluate to false in this case. If the boolean is false, it will evaluate to true. Similarly, if you have a value that is falsy, for example, the values that are falsy are 0, null, undefined, or also an empty string, thus like this, the empty strings that we have in the other set variables, they are all falsy values, it will convert to true. Okay, so it's the contrary. It negates the truthiness of that value. Okay, we have these two event handlers. Now let's create a function to handle the form submission, because when we will create the message, because when we will write the message to send to the OpenAI API, we need this form submission, and we need a handler for that form submission. And as a convention, usually it is named handle submit. So let's create another function, handle submit. Here I also will pass the event, and the first thing, I will prevent the default behavior of this submission form, because the submission form, when you submit, it has a default behavior like refreshing, etc. So I want to prevent the default behavior, and for that we use event.prevent default, just to prevent the default behavior of the form submission. Then I will set the loading to true, because initially it will be true, the loading. Then I will use a try catch block. This is complaining because it is async, so it is an async function. So we fetch the data asynchronously. And here we are sending a post request to this URL using Axios that we installed, and including the user's message in the request body. So this is the request body. This is the URL from where we are fetching the data, and we will create a server for that, okay, to get this API data. And the post request is when we post a request to the API. For detailed understanding of this, just read the documentation for the HTTP request. So get, post, put, etc. But basically, we are sending a post request to this API URL using Axios and including inside in the request body the message of the users. And then we usually put the headers. In this case, it's content type, it's application JSON. Then we extract the generated response from the server's response data. So we extract the generated response from server response data and update the teacher response with the generated text. So set teacher response, generated text. Then we set the loading to false once the request is completed, because it is not loading anymore. And this part of the catch is to catch the errors. If we have any errors, we catch with this catch block. So we console log the error, and that's it. So here, when the form is submitted, handle submit will prevent the default form submission behavior. We will set the loading to true then to indicate that the request is in progress, and we set the loading to true. Then we send a post request, also check the documentation of JavaScript for the HTTP requests like get, post, etc. using Axios. And inside, in the request body, we include the user's message. So the user's message is user input. Then we set these headers that the content type they are, in this case, application JSON. And we extract the generated response from the server's response data and update the teacher response with the generated text. So extract the generated response from the server's response data and update the teacher response state with the generated text. We pass inside generated text. Then we have this catch block to catch any errors, and we console log them. And here in the end, we set the loading to false. Okay, this is what this handle submit does. Now, finally, let's define the JSX structure of our chat component. For now, we just have a div component with a simple text. Okay, so this is the JSX structure. Okay, let's change this is loading state to loading, just loading. It's more clear. Loading, set loading. So in this JSX structure, we include a button to toggle the visibility of the input form, a conditional rendering of the input form based on show input that we have declared at the top, show input. So this is just a conditional rendering. This AND operator is if this show input is true, show this inside. We have this parenthesis. So if this is true, AND just means like show this. Show this. If this is false, it will not render this. Then we have this input form with the text input field and the submit button. And this is just the loading, if it's loading sending and if it's not, show the sent input text. And then in the end, another conditional rendering with the AND operator for the teacher response based on the teacher response. So if the teacher response is true, if we have the teacher response, if we get the teacher response, then show this div with the teacher response. You see here, we are just showing the teacher response. We will evaluate this state here. Whatever this teacher response state has, it will evaluate here. So we have set up our chat component to handle user interactions and communicate with the OpenAI API. But wait, we haven't actually created the server to handle the API requests yet. So now we need to set up a proxy server to securely communicate with the OpenAI API. So first, we will create a new folder called Proxy Server at the root of our project directory. So here, close everything. At the root of our project directory, we will create a new folder and name it Proxy Server. Inside this Proxy Server folder, we will initialize a new Node.js project. And to initialize a new Node.js project, we do it by running the command npm init-y. But make sure you are inside this folder. So for now, I am at the root level, cd proxy server, pvd, I am inside that. Or just right click and open in integrated terminal. So when we are inside this directory, npm init-y, and it will create this package.json inside. You see? We now initialized a new Node.js project. So these are the default settings for the package.json. Now we should install the necessary dependencies for our server, which are Express from Express.js. We will also install OpenAI from the OpenAI. We need the .env, which is a module that loads environment variables from the env file. Environment variables are to keep our secrets, okay? We don't push them to GitHub and we don't show them to production. So for example, the API key, we don't want everybody to see. So we put all these secrets to a file which is named .env. And for that, we need this .env package. And lastly, we need the course package, which is a middleware that enables cross-origin resource sharing, which is course for our server. So it's like a measure for security, and we need this middleware. So in the terminal, type npm install express openai.env and course. Always inside this proxy server, not in the other folder. Okay? So make sure you are the right directory and install these packages. Just wait a few seconds. And you see here in the dependencies, we have this list of course, .env, Express, and OpenAI. Now let's create a new file inside this proxy server folder and call it proxy.js. And we'll add some code there to create the server. So proxy.js. First thing, we import the necessary dependencies. And in this case, it's the same thing like we do with import module from module. In Node.js, there are two ways. We can use the modules with ES6 syntax, or we can use this syntax like const express require express, const API require OpenAPI, etc. We are importing these modules. It's the same thing as import express from express, import OpenAI from OpenAI. We can also convert this to ES6 syntax. We can do that by adding a line module in the package JSON, but we won't do it this time. You can do it anyway, but we are just going to use this Node.js syntax. I will just get rid of this. You see here, file is a common JS module. These are the common JS module. It may be converted to an ES module. Okay, quick fix, convert to ES module. You see, import express from express. We also can do this. Now, first thing, here at the top, we add a .env config to make possible to use our environment variables. .config. So if we have an environment variables from the env file, we load them using this .env.config, because we will create an environment variable for that after we get the API keys. So the next step would be to create this OpenAI key variable, and for that just declare const OpenAI, and here we create a new instance of this OpenAI class that we imported at the top. And for that, we use the new keyword to create a new instance of this class. So the new keyword is create a new instance of that class. So OpenAI, curly brackets inside, because it's an object and we use the key value, which is API key. And here we will add the API key when you will get it from the OpenAI platform. So each API key will be different. So you will put your API key here, but you don't want to put it here to make it accessible to others, but you will use what we mentioned, the env files, the environment variables. And to use the environment variables here, you type process.env dot the name of the variable that you declared in the env file, which usually should be just in uppercase letters. So OpenAI underscore API key. Okay, you will declare this inside the environment variable that we will create now a file .env to store these environment variables. Okay, yes, let's do it now. So new file .env, and it will be like this. Not rnv, env per case. .env, not just env. And here, without spaces, without anything, the variable OpenAI key equal, and here paste the key. So the key here, okay, without strings, just like that. And next, we create an Express application and apply the course middleware to enable course. Remember, I mentioned course. And to enable this middleware, doesn't matter to go in detail what the really course is. You can read on internet about it, but it's just a middleware for security. Okay, so we create an Express application and apply this course middleware to enable the course. So const app equal express that we imported at the top, and then we do like, and then we use this app variable app.use and pass course inside. This course that we imported at the top. And also don't forget app.use express.json. As you can see, this is returns middleware that only parses JSON, okay? And only looks at requests where the content type header matches the type option. You know what JSON is. It's the type of data with key values. And after that, we define a post route at API/ChatGPT. Remember that in our chat component, we are sending this access request, this post request to this API/ChatGPT that will run in our localhost 3001. So we need to set up this API route. And here it is. Follow this code. So we create this route API, pass this request and response parameters. We console log the request body here. We have this completion, which we get from this OpenAI chat completions that create, which is the way that OpenAI offers us to get a request from them, okay? And here we have these messages with the role system and the content, like you are a helpful assistant, or we can make it more specific here. You are a teacher and you will help students, etc., etc. You are an AI teacher and you will help students with their blah, 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 doesn't matter. You will help students. And the role is a user with this content with request body message. With this request body message is the message that we sent. And we are using this model GPT 3.5 because if I add this version 4, not everybody has, the premium. So let's leave it. And then we extract the generated response from the API response and send it back to the client as a JSON file. Okay? So response.json response this syntax from OpenAI. But what it means is that we extract the generated response from the API and send it back to the client as a JSON. JSON is that structure of data with key values like. And then, if an error occurs, we log the error details and send an appropriate error response to the client. Okay, so error details, we send that message. It's just that. And finally, we will start the server and listen to the specified port. In our case, the default is 3001. So we will start the server and we'll listen to this port. So const port equal process.env.port, okay? Or because we might have a port that is a secret, we don't want to show, and we can store it in our env variable. So we check port is what we have in our environment variable or 3001. Then we listen to this port and console log a message. Proxy server is running on port and the variable port here, which is 3001. When we will start the server, it will console log this message, telling us that the server is okay or if we have any errors. Well, that was a lot of code, but we successfully set up our proxy server to handle the communication between our chat component and the OpenAI API. And we can run this server with simply node proxy.js. You see the message, proxy server is running on port 3001. So we have this server running, okay? And we can make API calls to this server here in the chat component. We are making an API call, so we will get the data because the server is running correctly, okay? Now we just want to make sure that this access.post request matches the proxy server's endpoint. So we have localhost 3001/API/ChatGPT. Make sure that this URL here matches the proxy server's endpoint, this one here. Make sure because you may have errors and cannot figure why. This is something that you should check. So slash API ChatGPT. Make sure to match this. This is the base URL. It's the local host with the port 3001. And this is the endpoint slash API slash ChatGPT. Okay, with everything in place, we can start our React development server and the proxy server. So we started the proxy server with a node proxy.js. We run that file. And for the front-end part, we just, npm run dev. And now we should be able to interact with the AI teacher through our chat component. Okay, let's see what happens in the browser. Do not forget to import also the styles for the chat component. Now let's check the browser and see if we see the chat box and if we can make a request and if everything works correctly. Okay, let's discover. Okay, first thing first, I don't see the button ask me a question, so we might have issues here. Let's open the console log. We don't have any errors. Okay, let's refresh. We don't see yet the button ask me a question. So in order to ask a question and open the chat box, back to the code. Oh, okay. I know the problem. I forgot to call the component in the app.js. Wait. So yeah, we created everything, the chat component and also the proxy server, but we are not rendering at all this component chat because we should import it here in the main app component. So import chat. It will complain because JSX expressions must have one parent element. Okay, so if you have more than one component, you should add like a wrapper in parent. You can add a div or empty. How it's fragment? Yes, fragment. Empty fragment, like this. Okay, wrap it with this empty fragment. Now we should be able to see the button ask me a question, and when we click the button, we should be able to open the chat box and send a request and everything. Okay, maybe not yet, but yeah, it's just a stupid error, just this import for the chat styles. I forgot to add a slash. So here, a slash. So we see the button, and let's test it. Ask a question. We see the input form. So it works. And let's check if the server sends a response or an error. Let's hope that it has no errors. So an easy question like what is ChatGPT? Okay, it works. We get the response, you see. It opens this dialog and everything is functional. We have no errors. Let's check the console. No errors. Everything works perfectly. We just need to style it better, of course. We will add better styles, but it's functional and everything works correctly, as it should. We can continue to the next section. Maybe we can add like a conversation window where we see our question and the response from ChatGPT. So in a structured way. So user question, then ChatGPT response. Okay, so we label, and also we can find a way to save the conversation. So we have a history of that conversation. It would be cool, right? because we want to save the conversation and continue the conversation with other questions. Because now we close it and, for example, this box here remains, it should close and it should erase also after I close the chat. So everything should turn to an empty value, should be erased, and we will work on that. And after that, in the end, we will add the voice recognition, so I can ask a question with my microphone. So I want ChatGPT to respond me with an audio. Let's do that. So in order to add the feature to save the chat history, I made a few changes in the code. I didn't wrote the code live because in React, when you make changes in the JSX structure, it's a bit confusing. So I don't want to confuse you. So I will explain the few changes that I made. So first of all, I added a new state variable, chat history. Okay, chat history, set chat history. And the initial value, it's an empty array because this array will contain the chat history. Next, in the handle submit function, I update the code to save the user's input and the generated response. So scroll down to the handle submit function. Here, you see, this is the same. The generated text is equal to the response that we get from the data. And here, I update the chat history with set chat history. First, I spread this chat history, everything that already is in the state, and then the user property stores the user's input message, user input, and the bot property stores the generated response from the AI teacher, so the generated text. I then use the set chat history function to update the chat history state. The new state is created by spreading the existing chat history array. So this is by spreading the existing chat history array and then appending the new object, user input and bot generated text. Finally, I clear the user input state by calling set user input to empty string. I clear it. And to allow users to clear the chat history, I use this handle clear. Okay, with that I set chat history to an empty array and also set user input to an empty string. And I will use it when I will click the button, close, it will clear the chat history and the user input. You see, I add this onClick event listener in the button, and every time we click this button, which is the cancel button or close, we will erase the chat history and also the input. Okay, this is the clear button. Then this is what happens in the updated JSX. First, I check this chat history length, if it's equal to 0 or greater, if there is anything in the chat. So in this div section, I check if the chat history array is empty, using this chat history.length equals 0. So if it is empty or not, then if it's empty, I will display this text message. Welcome to the chat, ask a question to start the conversation. If it's not empty with these two dots here, so this is a conditional. In React, you use the curly brackets, use this conditional, chat history.length equals 0. This is the ternary operator, and the ternary operator works like this. We have this condition, is chat history length 0 or there is any chat there? And we put this question mark. Is this length 0? Yes. If yes, it will show this div. It will evaluate this condition. If it's not, the other condition is written like this. These two dots, open parentheses, and evaluate this other condition. And in this case, this other condition, if the chat history is not empty, we use the map function to iterate over each item in the chat history. The map function is a JavaScript arrow method, one of the most used in a React project. You can learn about the map function, search Google, check the documentation. But basically here we iterate over each item in the chat history. And the chat history is an array. And then we render a div for each message response pair. Okay, so we render a div for each message and response pair. You see, this is for my message and this is for the response. For each item of this array chat history. That could be a long conversation. So inside each div, I display the user's message with a U. Okay. And here I put inside chat.user that I showed you earlier. So user, which is the user input, and the bot is the generated text. And here I show chat.bot, which is the generated text that we define here when we get the response and we set the chat history to it. Well, that's it for these changes. It's simple. Once you learned how to manage the state with useState and its state variables, it's not that hard, I think. Now, with these changes, our app supports the chat history functionality. Okay, we can check now the browser and test it. We also have the new design. Let's test it now. Ask a question. You see the new design. It's better. We get this initial message and we do this with that condition. Remember that if the chat history array is equal to 0, so if it's empty, then we show this div. If it's empty, we will show the conversation. And here we can type message. Let's test it. So again, what is ChatGPT? Okay, you see, it looks very nice to me. We get this chat. So now we see you and our question, and then ChatGPT with a response. And it works perfectly. Okay, I'm happy with this. I think we are finished with this part. Yeah, the last thing is to add the text-to-speech and voice recognition. I wanted to add a nice audio, maybe use 11 labs or use the ChatGPT text-to-speech functionality. So we are going to do that, and maybe later we can further improve it by using a better audio. Like I know this platform, 11 Labs, maybe we can use that somehow. I don't know how, but I will figure out. Or maybe you can contribute to this, since this project will be live on GitHub. If you want, you can contribute. So if you know how to do this or other features, please go ahead and send a pull request and we can share it with everyone. Okay, so close. It will now delete everything in the chat history and also the input. So again, oh, it doesn't work. Okay, it's this clear. Okay, clear, yeah. So when we click the clear, it will clear everything. Now close. Okay, it works. We have reached the end of our tutorial on building a 3D AI school using Three.js and React Fiber. I hope you found this tutorial informative, engaging, and fun. Building a 3D AI school is just the beginning, actually, of what you can create with the power of Three.js and React Fiber, and additionally, AI. As we move forward, there are countless possibilities to expand and enhance this application. In future versions, we could explore many other cool features like integrating realistic voice synthesis to give the AI teacher a more lifelike and expressive voice, and personalize the learning experience by tracking user progress, providing tailored content recommendations, and adapting the AI teacher's responses based on user preferences. The possibilities are truly endless, and I'm excited to see what you will create with the knowledge and skills you have gained from this tutorial. I want to thank you for joining me and for your dedication to learning. If you enjoyed this tutorial and found it valuable, I would love to hear your feedback and see what you create. So feel free to share your projects, ask questions, and if you want, connect with me by subscribing to my channel. And also, you can add me on LinkedIn, where I post from time to time things related to the world of 3D web development. Once again, thank you for following along, and until next time, keep learning and keep exploring the fascinating world of 3D and AI. Bye.